Hello all and welcome back. So in this video, let us now continue our discussion on trees. And now let's try to do a question which is in front of us. So the question says that we have to construct a tree given the in order and the pre-order. So let's get started. Now in the last video, we saw that what exactly these traversals are. And here we are going to actually use them. Okay. Now many of you might be having the question that why not, let's say, just pre-order. Okay. So let me make a tree. This is a tree for which I have the pre-order as 1, 2, 3. Okay. But for this tree as well, the pre-order is going to be 1, 2, and 3. But these trees are not the same. Okay. So just making a unique tree from given just the pre-order or the in-order is not possible. We require both of them. Okay. Great. So now let us see. So via this question again, I would like to explain that how you reach these kind of question. Okay, so like how exactly, what is the approach in my mind which I follow if I'm given this question or I'm just attending this question the very first time, given any data structure or any overall concept, I would say. The very first thing, what I believe is that we should write what we know. Now, I know that my in order is first the left subtree, then the root, and then right subtree. Okay, so this is some knowledge which we are aware of. In a very similar way, we know that the pre-order is root, left subtree, and right subtree. Now, this is the knowledge which I have. Along with that, I also know that I have to think of my tree something like this. That each and every node is a binary tree in itself. Something which we have actually seen from the lots of videos. Now, what you should do once you have all the knowledge which you know for a concept, in solving any question in general, you should now take an example. So let's go back. In the last video, we found out these traversals. Okay. I believe it is very helpful if you can somehow save or get these traversals. So let me do one thing. Let us try to just get this knowledge into our notes. So the same approach you will be following when you are solving any particular question. Great. So now I have the pre-order and the in-order for me with a particular tree. In this, I will see if somehow I can apply something through which the same can be solved. The idea is that if I'm able to apply the concepts, the knowledge which I have, and I'm able to take and run it on one example, is it taking me somewhere? If it is, and if the same understanding is helping to solve lots of test cases, then I think we are on the right path. Yes, there can be some edge cases or something which we are going to handle. Great. Now I have the example in front of me as well. So let's see how exactly will that roll out. Now in this particular example, I have the pre-order with me. So let us write that down. Pre-order is something 1, 2, 4, 5, 3, 6. Similarly, we have the in order as well. In order is something like this: 4, 2, 5, 1, 3, 6. Great. So now we have an example with us. We have all the knowledge. Now let us see how we can solve it. Okay. The very first intuition or the idea which I am getting just by thinking out loud is that if I am able to do my work for the node and just call recursion on my left and the right subparts, it will be able to do something. Why is that? Because the tree which I'm creating, each and every individual tree will be having its own in order and pre-order. So, for example, let's say this is the tree which we have created, which we have to rather use. For this particular tree, what exactly is going to happen? Let me get this tree as well in the notes. So, let me make it a little small. For this particular tree, what exactly I'm saying is that we can actually imagine something like this again, right? So, this is one subtree and this is the other subtree. Now, this subtree, because it's a complete binary tree in itself, it will have some in order, it will have some pre-order. If I'm able to just solve for the root and say to recursion that, hey, I'm giving you the pre-order and in order of left subtree, and I'm giving you the pre-order and in order of this right subtree. You go and make, I'm just going to make for the root. I think we will be able to do our work. Okay. So let's see how that pans out, everyone. The very first thing which I think we all need is the root. So root is 1 in this particular case. Now again, you have to make sure that you are running and building your logic with the help of an example. There is nothing wrong in that. Rather, that's the best strategy to solve question out there. Just make sure of one thing. Don't let or overgeneralize on example. Like you're taking a lots of help, or let's say you're not applying any concept even and just trying to solve the example. No, you are trying to justify your concepts with an example. Root, I believe, is very easy to found. We have the root right in front of us, which is in my pre-order. Okay. Again, from in order, I cannot say which one is the root, but from pre-order, I can always say that, hey, this is going to be the root. Great. What does that mean? That means that I can actually draw and say comfortably that 1 is going to be my root. So let me draw 1 here, everyone. I can say that 1 is my root. Great. Now, going forward, what I have to do, I'm saying that if I'm able to call properly on the right and left part, then I will be able to create my tree. Great. Now let us move forward and see how can we get the in order and pre-order. What is recursion at the end of the day? We have discussed the recursion is when you are trying to solve a problem which depends on similar smaller problem. In this problem, I am trying to make my tree from in order and pre-order. If I am able to just make my problem small, that is, if I am able to make my in order and pre-order small and sending it to my recursion, then I believe that will be done. Great. So let us now see how exactly can we find out. The first approach which I believe can help us is we have the root of basically our main tree. We have the root. We can go in order and find where the root is. We can go in order and find where my root is. Okay. Now once I have the root, I can comfortably say that the left part of my root is the in order of my left subtree, right? So what exactly am I saying? In order of my left subtree is going to be this 4, 2, 5. How I know that? Because I found out the root from pre-order and then I find the same in order. And again, we are taking that no duplicates will be there, because if duplicates will be there, then it's going to be a problem. We might have to then work on the references of the nodes and not the data. Great. That's the very first thing. Second thing, similarly, I can say that the right to the end is going to be my in order for the right subpart. Great. So I believe that is clear. Now let us move forward, everyone, again to see what exactly is going to happen. Now I need to find the pre-order. But how can I find the pre-order? Because this is the pre-order I have for my full tree. I know that this is the root. But this pre-order can be this long as well for the left one, can be this long as well for the right one. Okay. But here is one thing which I can use. If you will see in my root, in order and pre-order, the length of pre-order and in order is same. It consists of 6 elements only. Why is that? Because again, in order and pre-order, it is having all of my elements. So always their length is going to be same, right? Always their length is going to be same. Great. If that is clear, then I think you can actually do one thing. You can use this knowledge. The knowledge which I'm asking you to use is this length. This length. We can say that in our pre-order, starting from root plus 1 index, okay, if this is the root index, then starting from root index plus 1, if I take exact number of elements which are in my in order, in this particular example, that is 3. If you can see in front of us, 4, 2, 5. So I'm sure that my left subtree will be having 3 elements in its pre-order as well. Then I can get this particular left subtree pre-order. In a very similar sense, I know the length of this and I can get this as well. Though it would be a lot easier now because you have found the left subtree pre-order. So you're sure it will start from the next element from it. Okay. So on that note, what I can write as well. Now I can say that my pre-order is going to be, for the left side, it is 2, 4, and 5. For the right side, it is 3 and 6. And I think recursion is now going to do the work pretty nicely for us. So now recursion is going to make a tree for us based on this knowledge. Again, it will call, it has this root. It will see that, okay, root is there, the left subtree, the right subtree. Similarly here, it has the root. It will see the root here and will call on the right subtree because left is not present. And we will be able to create our trees, which will be something in the manner which we have seen. So internally recursion will make the root. Here also it will make the root and then call for the left part. So left part this time will be just 4. Right part will be 5. Here we will see just the right part which is going to be 6. So this is the in order. Same goes for your pre-order. Pre-order it's going to be 4, 5 and 6. So we know that node 4 will be created here, 5 will be created here and 6 will be on the right side. Now I think we can just in a way mark these nodes, create them into a proper node. And if you will see, our tree is getting made. So tree in a way is in front of us if you just see the green part. Okay. So pretty sure that the overall concept is a lot clear with this level of detailed understanding. Let me just now tell you how we can do the same thing. So how will we be doing the same in the code in terms of code? Okay. So let me do one thing. Great. So we have created a copy. Using this, I'm going to explain that how exactly we are going to make our question to use recursion. Great. So what I'm going to use here in this particular case is something which is to break my pre-order and post-order, right? Something we have done in, if you all remember, recursion question as well. So I will be using indexes. Okay, I will be using index to break my in order and pre-order. So I need to tell my recursive calls, right? That where the pre-order is starting and where it is ending. So I think I need multiple things. I will initially start with this particular understanding, which is going to be in my code. I will have, let's say it's construct tree. Okay. I will get the in order. I will get in order, pre-order, in order start, in order end, pre-order start, pre-order end. So I'm not going to make the copy via slicing. I'm going to use the indexes because that is a lot optimized and a better way. Great. Now what I need to do is I will be calling on left and I will be calling on right. And again, the understanding is going to be the same. I will send in order and pre-order, but these four values are one which is going to change. And similarly, here also, I will have these four values. So I think I just need to now find out these values, which is left in order start, left in order end, right in order start, right in order end. Sorry, left in order start and left in order end. So everything for left is here. Similarly, everything for right will be here. Right in order start, right in order end, right. Once again, I think I made a mistake. One second. Sorry for this. So when we are talking about left, just there should be left pre-order start, left pre-order end. Similarly, here it will be right pre-order start, right pre-order end. Okay, great. So if I'm able to now find these 8 things properly, then I can always be sure that overall I can make the recursion call. And yes, it is in this way only we will have to pass the overall idea, because even in dividing, you will be needing these things, right? Great. So now let's see for these particular values which we are finding, everyone. Now we know that we have the root index. Let's say this is root index. For left subtree pre-order, for the left subtree pre-order, what I can say is the start. I think it's pretty easy. The start of my left subtree pre-order is root index plus 1. Okay, great. The start of my left subtree in order, start of my left subtree in order is going to be in order start only. In order start. Because I'm starting from here, right? So again, this is going to be a little complex, so pay a lot of attention, everyone. What I'm saying effectively is that from where my in order starts, that is where from my left subtree in order also start, which we can see in front of us. Okay, great. Now let us move forward. And let me just write in these as well. In order start, in order end, pre-order start, pre-order end. Okay, great. So maybe instead of root minus 1, what I can write it as, everyone, now because it will be a lot clear, it is pre-order start plus 1. Okay, nice. For the right subtree, and please pay a lot of attention again, for the right subtree, the in order and pre-order ends at where my overall in order and pre-order was ending, right? So in order and pre-order end. So I can write this as well. For the right subtree, in order ends where this was ending, and pre-order end where pre-order was ending. Great. So I think we have done a lot of, we have found 4 values pretty nicely now. Now let's talk about the how we can find the end of my in order. So I'm saying now end of my left subtree in order, this particular value. Okay. For this, I have the root. What I can do is I can run a loop and see where am I finding this particular value here. Let's say this index, this particular index is something which is root index in order root index. Okay, INRI, in order root index, in order root index. Once I have this, then what can I say, everyone? So pay attention. The left subtree in order, left subtree in order ends 1 before this. So it's going to be in order right root index minus 1. Okay. Now, once I have this particular knowledge, I can find out the length. I can find out the length. How can I find out the length? Because this is going to be equal to this. And I think I have this overall thing and I have these two as well. Right, everyone? So I have these two and I have this as well. So what effectively we can say? We can say that left, we have these four values. If you will say we have these four values. Okay. And left in order end minus left in order start is going to be left pre-order end minus left pre-order start. So we can find this value as well. Okay. So this value is also done. We have to find this via subtraction because the length is same. Now let us come back to right. Let us come back to right. Once I find out this value, left pre-order end, which is this particular value, all I have to do for this right pre-order start. So I'm saying right subtree pre-order start is left pre-order end plus 1. So it is ending here. Okay. And once I have this 3, again everyone, once I have these 3 values, I know the length part. So this minus this is equals to left minus this. So let me write this as well, everyone. Left pre-order end minus left pre-order start is equals to left in order end minus left in order start. Similarly, right pre-order end minus right pre-order start equals right in order end minus right in order start. Okay, so we have found these four values. Now all I have to do is to just send them on to my next recursion call. Using this particular case, so I can just say that using this particular equation, we can find this value. Okay, great. So yeah, I hope this is clear, everyone. Now, what I will expect is that you are going to write the code for this particular function, this particular problem. Again, we have discussed this in a lot of depth. Like really, we have gone to a lot of depth. Everything is in front of you. Refer to this particular sheet which we have created. I think it has everything which you want to know. Yes, you will have to pay attention, you will have to focus a lot, but believe me, you will be able to write the code. Even after this analysis, I was able to write the code in like half an hour, but I would expect that you will also be spending the same. And in the next video, then we are going to write the code for this, where you will see how useful this whole analysis is going to be for us. Okay, so great, everyone. Now please just try this at once at your end, and then let's meet in the next video where we will be solving this. Thank you.